The last sense I want to talk about is your sense of touch. And if we look at a section of your skin, what we would see is that there's several receptors in here. For example, this is a Pacinian corpuscle. This is a Meissner corpuscle. They're free nerve, whoops, I can't really click on them, but they're free nerve endings. And all of these things are going to sense different, um, different types of touch. For example, the free nerve endings are going to sense pain. Some of them are better at sensing vibration. Some do hard touch, some do soft touch. And all of this together allows you to sense that when your skin is being touched. However, the thing that I wanted to talk about is really how do you know the location of where you're being touched? And this is something that hopefully you saw in the lab. You were looking at a 2-point threshold, and a 2-point threshold is the smallest distance where your body can still tell that there are 2 points. And it turns out that this distance is much different on your tongue, which is very sensitive, or your lips, which are very sensitive, than it is on your back. In fact, you've probably had problems if you've ever asked someone to scratch your back, having them find the right place to scratch. And it's because the difference between those 2 points is so large that you can't sense it. Where does this come from? It turns out on your back you have very few receptors and they're very, very far apart. What this creates is a scenario where if you think about having only 3 receptors and they're very far apart, my ability to tell a stimulus that's here from a stimulus that's here is kind of limited because the receptors are just going to be slightly activated, and I may not necessarily notice any difference between those two stimuli. However, if I have a lot of receptors, now this makes it so that I can triangulate the stimulus. So in this case, these receptors would be active, and in this case, these receptors would be active. And since those patterns of activity are very different, that means that I can tell the difference between those two stimuli. Now, we saw something like this in the retina, where in the fovea you have more receptors, and since you have more receptors, everything's a little bit clearer. It turns out the same exact thing is going on your skin. The more receptors you have, like on your fingertip, the more easy it is to tell 2 close together points apart. But the fewer receptors you have, the harder it is. Now, it turns out that the reason that you don't have a lot of close together receptors is twofold. One, you'd have too much information, and 2, you'd be all neuron and no substance. So you kind of have to prioritize the information, and we prioritize it to certain regions of our body, like our hands or that fovea, so that we're only processing detailed information from a small number of places. In your brain, this actually creates a really cool thing that we call the homunculus. And the homunculus means that the more receptors that you have going out to an area, the more have to come back to your brain. So if we look at the part of your brain that represents your lips, that's going to be much larger than the part that represents your back, and you can see that here. Or the part that represents your hand is larger than the part that represents your elbow. Now, missing from this picture, because it is kind of awkward, is the genitalia. And normally in a homunculus, the genitalia are really large too, because that is a very sensitive area of your body with a lot of nerve endings, and they have to go somewhere. And since they're going to the brain, a larger part of your brain is dedicated to your genitals.